Okay, if you have a digital SLR with a telephoto lens with some extension rings or a telephoto macro lens, and you have many thousands of slides to scan, either in stacks or in some kind of proprietary magazine or carousel like the Kodak here, I've put together an automated system that will advance the slide and give a proper amount of time to wake the camera and to fire it, depending upon the process you want the camera to do. You could have it go much faster if you have it wake and fire at a fixed exposure. If you're going to actuate the autofocus or the auto exposure on the camera, you would put an extra dwell time between the waking of the camera and the firing of it. So this video is to show the build, and I'm going to show you every step of the way, so stay tuned. So obviously, if you had just a few slides, or maybe just 100, you'd put them in a flatbed scanner and scan them, or maybe you'd set up a quick rig where you'd have build a little light box and you'd set up your camera on a tripod with a macro lens and put them in front of the camera individually. But a lot of people have a lot of slides and they're already in carousels, or for instance, my late aunt had a Bell & Howell cartridge system, and there's got to be maybe 200 boxes, each one holding maybe 3 or 4 dozen slides, and it's this proprietary box, and you'd have to take each slide out individually because each one is in a frame, in a slide, in this box, and it feeds through the thing sequentially in a rectangular cartridge. So whatever system you have, slide projectors are very cheap to buy these days. They're not in high demand. You can go on Craigslist and get a working projector very reasonably. So if you have your own digital SLR, this is really the way to go to make some quick scans. Given the high pixel count of a 36 or 40 megapixel SLR camera, like the Sony Alpha R2 or even this dated Nikon D800, if you're scanning at that rate for a 35mm slide and you can pretty much fill the frame, you're going to be scanning at about 4000 dpi, and you can capture it in the RAW format or as a JPEG. So you're going to get some really nice images this way. So the objective here is to convert your slide projector and your camera at minimal cost with a few extra components into something that will give you a high output and pretty high quality. There's a parts list in the description, and there's 2 different ways I've proposed to do it. One is to use a motor-driven mechanical rotary switch, and that would require no hacking into your slide projector. You would just put a lower wattage bulb into it and add a couple of things like a diffuser. If it's still too high a wattage a bulb that you can find compatible for your slide projector, you might need a neutral density filter. But there's also another system. If you can hack into your slide projector, and I'll show you how on this particular slide projector. If you can hack into it so the slide projector itself gives a signal whenever a slide is chambered, and that could be told to tell the camera to either wake and fire the camera, then you could do without having a complicated system. You could get a pre-wired module that are very inexpensive and ubiquitous that could send a pulse at a regulated rate with a regulated dwell time to the slide projector, and just tell the slide projector to advance and then wait a certain amount of time before the next advance, and let the slide projector tell the camera to fire. And that would be an even more simple system. But either way, you're going to have to get an adapter to adapt to your slide projector to tell it to advance, and you're going to get a remote cable for your camera, whatever make or model of your camera it is, to tell your camera to wake and fire. So I'm going to show that in the video, and we're going to do the build. And as I said, the parts that you need are in the description. And you could use any kind of connectors you have. I chose certain ones because they were cheap, readily available. Patch cords are easily available. You might already have some, especially RCA cords. Everybody has them. So this was really the most cheapest, efficacious way. That's plug and play, and you don't have to do, once it's wired, everything is going to be just plugging in patch cords. So the system then is not going to be kind of a rickety system. It'll be one that is pretty substantial, and you can pack it up and take it out of a box and plug it in, and you can be rolling with it within a few minutes. The Prints and Photographs division kindly lent me this reasonably modern Kodak Ectographic 3 carousel projector. It might even be autofocus. It definitely has a motor focus, and that's kind of an exciting option because there's going to be a switch in there that turns off the autofocus so as not to confuse it when the slide is advancing. You could use that switch in there to tell the camera to fire, so you wouldn't even need to have the elaborate 2-pole timer that I have in this video. You could use a simple pulse module to tell the projector to advance with a certain pause before the next advance, and those are off-the-shelf items that are very cheap. And you could tell the slide projector to fire the film once the slide is seated in the chamber. But that's enough for another video. Let's talk a little bit about this projector first. This one, I believe, has the more modern bulb that is 82 volts instead of 120, and it's a smaller size. I've got an older projector at home. It's one of those Kodak, I think it's a 750H from the 1960s, and those use the 120 volt large MR16 bulb. I don't know if I have it. This is an MR16, it's not the right bulb. This is a 12 volt bulb, but it'll be 120 volts. It has the Kodak 750H has 2 blades instead of 2 pins, so it has a GY 5.3. That kind of limits your options for bulb replacement, because you will want to have a bulb that's less bright, and that also is it doesn't run as hot. Not that these things can't take the heat. These are designed to have 300 watt bulbs in them. They have ample cooling, but it's just going to be too much light for your purposes. You're not projecting on the wall anymore. You're going to be shooting right into the gate and shooting the slide. So on any of these slide projectors, including non-Kodak ones, you're not going to need the lens anymore. That can be removed. So we're just going to remove it, and it comes right out. This one is a zoom. How nice. And you can see there's the gate way in there. I don't even know if you can see it. So that's why we're going to need a long lens. Now, if you didn't care about the slide projector and you didn't need it to ever be a slide projector again, you could use a cutoff tool, cut in here, and so you could stick your lens right in there. You could just gut this thing and use a 50-55 macro or something like that. This one, obviously, it's not even my projector, so I'm going to have it so it returns to stock. And so I'm not going to be cutting into here at all. We're going to use a 105mm lens, and it's going to be up almost touching this thing, but away from it. And we're going to frame it up nicely so we can fill that frame in there. But we are going to have to do something about the lamp. Now on this one over here, they've got a module. The older ones, you just replace the lamp from inside. There's a reading light, but also it's a good hook to remove and open this thing because you have something to hold on to. So you're going to see that there's a module in here, and there's going to be a release tab. Here it is right here, and you press it and the whole thing's going to come out. Now you can see the gate where the slide projector is. Inside here there's already a nice condenser in here. Let me show you this. All of these Kodak slide projectors, this one gets its power right from the unit when you slide it in. There's the power input right here. There's a condenser. It's very dusty. I'm going to have to clean this whole thing out. It's a good opportunity to clean and lube it. But you have a condenser, and look at that thick chunk of heat-absorbing glass you have in here. That's a greenish one you see in there. So you've got a lot of protection for your slide. And this thing is custom designed with a mirror to take the light from here, and it's been engineered to give you a nice illuminated field with no hot spots. The only thing is, because you're looking straight into here, you're going to want a mild diffuser before you get to the slide gate for your camera, so you don't get any artifacts coming out of the glass here. You're not focusing on anything but the slide. The downside is the specular light and the focus light from the condenser makes for a real sharp photo. Anytime you use a diffuser, now you've got light going every direction, and it really knocks down some of the sharpness of a slide. If you've ever used an old enlarger and used maybe a zone 6 head for the light source, you know, it's a lot more softer than the condensers. But if you keep this thing stock and just put a lower wattage light in here, and there are some options. For instance, for this one here, this is a very high output. This is probably going to be maybe an FHS bulb or one of its sister bulbs. Let's open it up and find out. There's your ejector. Never touch the front of the lens, because the oils in your hand will become acid in the high heat, and it'll shatter the bulb. This is actually it's an EXR. That's even, well, it's also 300 watts, but it actually burns a little hotter, and that's why it has a shorter life than its sister bulb, the FHS. But yeah, here it is. It's got this gorgeous dichroic reflector in there, and it is a quartz halogen. But you can replace it, and here's a good replacement. This is a GE EZE bulb. The EZE is also the same size. It's an MR13, has the same GX 5.3 base, has the same beam spread, and in fact, it's a little bit has a higher temperature. It's this 3300K instead of 3200K, and it has 100% CRI. It has full spectrum, so this is a very desirable bulb, and it is 150 watts, so you've knocked it down quite a bit. Probably still a little too bright, but you could always put a neutral density filter in the gate there with your diffuser, and this is going to be perfectly matched. But there's another thing you could do. You could just take this entire assembly out and not use it, and inject your own light in here. You could have, like for instance, I've got this 12 volt bulb right here. I could put it in my own caddy with its own diffuser. This is 4700K. It's a photographic quality light. You drop this in, and now you've got something. You have to do your own supply, whatever the appropriate voltage is for your bulb, because you're not going to be running off the 82 volts in here. And you could just put it right in here, and you have it. Or you could use a fluorescent bulb. A photographic LED, but the LEDs, you got to be careful, because they might not be full spectrum. They may not be 100% CRI. They might have hot spots, because LEDs are highly directional. Usually there'll be more than one element, and you'll have a pattern. If you use an LED, I would put in 2 diffusers. I would have a diffuser first, and then that will diffuse the light, and then I would still have my secondary diffuser inside there. But whichever way you do it, I would recommend trying to get the lowest wattage that you can, because you're looking for about 50 watts, 35, 50 watts, maybe 85 watts. But you don't want to have higher than that. So with this 150 that I'm going to replace this one with, because it's a drop-in and it will work so wonderfully, I'm going to use a neutral density filter. I have a Ratten, I think 0.90, which is 3 stops, and I might cut that to size and drop it in there. But tell you what, let's pop this thing open and see what we have inside, because we need to clean it, and it'll be a lot easier getting in there to put our diffuser and our neutral density filter, in this case, if we get it open. And we're going to open this from the bottom, and there's going to be a couple of screws in. Sure enough, there they are. So let's pop this thing open and see what it looks like. Now with the thing I have here, I can put in any voltage bulb I have. This 4700K one is 12 volts, and so I need my own 12 volt supply. If you put an LED bulb in here, you're definitely going to need your own supply. The LED is going to need its own special dedicated power supply that is limited not only by voltage but by current, so you don't burn out your LED bulb. You're going to have to carefully look at the specs of the LED bulb you have to make sure that it's up to snuff quality-wise in terms of light spectrum, and that you're feeding it the proper current and voltage. It turned out there was an extra bolt to screw in here, so 7 screws holding this one on. Gee, the 750 at home only had 4 screws to take it out. This one did not want to pop open easily. It's resisting it, probably from being closed for so many decades. So here we go. And what do we have? Oh my gosh, it is dusty. Very dusty. Look at this. Look at, oh my gosh. Look at the cap on the fan. Oh my gosh. All right, so this needs a little cleaning up. But, oh joy, look at this. There's that position switch. Wonderful, wonderful. This is a normally open switch. Maybe it's a normally closed switch. I'm going to have to find out. But this actuates when there's a slide in the chamber. You could use this if you're willing to temporarily disable the focus, the autofocus on this thing, which you're not going to be using anyway. You could use this to shoot the camera. I'll have to do that for another video. Or maybe I'll tap into it this time and put it at the end of the video, show how to use a pulse unit with this instead of using the double timer, the mechanical timer. But okay, let's clean this up, and then we'll get the diffuser and the neutral density filter into the chamber here right before you get to the slide stage. Okay, you're going to see in there that there's a guard that keeps you from having raw light going onto your screen when there's no slide in the gate. And when you hit the advance, it's gravity fed. And when you get to a slide, it senses that the slide is in there with that switch, and it opens the gate, and you can see, maybe you can't see, it's so far in there, the slide is way, way in there. So you could see how life would be a lot easier for you if you were willing to sacrifice your projector, get a cutoff wheel, and cut all of this out so you could stick a lens way in there, because the focusing pinion, everything here you'd want to cut out. But we're not going to do that. We're going to do it the old-fashioned way and read off of that lens, that slide that's way in there, 1-to-1 with our 105mm lens. Here I'm using the light from the cell phone to show you what the slide looks like from the light side. With this particular projector, it would actually be easier for you to shoot from this direction and illuminate the slide from the lens side. But let's stick with the original plan, because I want this to be a universal video for all projectors, not just for this one particular model. Okay, interesting news. This switch, this is your common, this is normally closed. This one is normally open. So when a slide is seated, this will close, and it will close the circuit between this sawed-off pin and the common. So I could tap these two, run 2 leads out to an RCA jack, and have this let the camera know either to focus, to wake, or to wake and fire. So that's interesting. Not important for you for the purposes of this video, but if you do want to have just a timer circuit, set off the slide projector and have the projector tell the camera when to fire, this is useful. So I'm going to put some leads on, but you do not have to. What we're going to do next is to slide in a couple of diffuser and a neutral density filter. And in fact, I have one right here. You could use any kind. This is a Kodak Raton 0.9. That's an ND8 rating, which is 3 stops. And if I'm going to handle it, I'm going to use cotton gloves. But there it is. It's got a piece of dust on it already, but there you go. Raton ND filter 0.90. So that'll give me a nice 3-stop neutral density knockdown of the light coming in. Between this and the diffuser, we should have a really nice image, and the fact that I'm going to use a 150 watt light instead of the 300 watt one, it should run cooler and will have the right amount of light delivered to the slide. It'll be gentler on the slide too. And with the other stuff that's already in here, like the heat absorbing glass and the mirror, the slide should be really well protected if you have delicate collections that you were previously hesitant to put through a slide projector. I didn't follow my own advice about procuring some frosted sheet plastic. I thought I had some laying about. I found a rigid piece and I cut it down to about 2.5 square. On this model it fits a little better if you cut out some small notches. And to this, because I'm using such a high power lens, a high power lamp, 150 watts, I've cut out a corresponding neutral density 3-stop filter. So we're going to sandwich it and put it in right here. Right before we get to our lens stage, here's the lens right here. Here's where your slide is going to be sitting. So let's turn it around so we have the diffuser facing the slide, and we'll have the neutral density part facing the lamp, the final condenser to the lamp. Okay, that thicker translucent piece did make it a bit of a snug fit, but there it is in there. You're looking at it from the lens side, and a slide would be right there in the chamber. So it's looking good. And the neutral density side is facing the condenser on the light side over there. So all's good. There's this cargo area here, probably for a cord or accessories. Way down in here would be a nice place to hide that little camera trigger, just in case we decide to use it. Again, we're going to go from the common to the normally open over here that's been cut off. There's enough real estate here that I could tack in a little wire and then solder one to here, run both leads in, and then we'll have a completed circuit when there's a slide in the projector. That would be pretty neat, because that way the camera will not fire unless there's a slide in there. So if there's an empty part in a carousel, or the carousel runs out of slides, you won't be shooting anymore. So let's do that. Not necessary though. If you're going to use the distributor system that I have, you're not going to have to alter the slide projector in any way besides dropping in a lower wattage lamp and putting in a diffuser. And if the wattage of the lamp is too high, put in a neutral density filter. Okay, so we have the 2 leads here to the normally open, here to the common, and we just tapped in a couple of leads for our camera. Not necessary, but it's going to be fun to do this as an experiment and see how it looks. The slide projector will still be stock in every way, so I haven't altered its function at all. And the jack is going to be unobtrusive here in the side. But really all I had to do for the slide projector for this project was put in the diffuser. Because I'm using a 150 watt lamp, so it's still pretty hot, I'm using a neutral density filter, and we just have to put our replacement lamp into the housing, which I have cleaned out and dusted off, and then it'll drop in right there. And then we're ready to put this back together as soon as I put the plug in right there. and then we'll fit it together, get these casing pieces back on it, and the trim pieces, and the 7 screws, and we'll be ready to proceed. You might be wondering about this huge resistor over here. They're using this as a primitive way of knocking down the voltage to the lamp for the low setting. You can use the low setting for focusing and for tests, but it's going to affect the color temperature of your lamp. So you're going to want that at your high setting when you're shooting. But that's what that's all about. And that'll also help prolong your lamp if you have it at the low setting for setting things up, and then switch to the high setting when you're actually shooting, because this is a high output, high performance lamp, and it has a certain amount of hours of life to it. So you don't want to jolt this or jar it, drop it. You have to be very, very careful. And again, never touch the center of it with your bare hands. Keep it clean, and it'll serve you. Later in the video, I'll show you how to tap into the slide advance switch. This is going to vary depending upon the model of slide projector you have and what make, what model. You might have a slide projector from some totally different company. If that's the case, you can tap into the actual slide advance that's on your unit, or in the case of the Kodak one, if you don't have your remote control unit, you could tap into the appropriate pins of the slide advance right here. And you could just put 2 leads right into the port over here. But since we have a remote control, a corded remote, we're going to tap into the corded remote, so we're not doing some slapdash setup where we're putting wires into pins. We'll have it nicely wired into the remote. We're back together, so let's test out the switch we put in. You can see that there's no continuity when there's no slide in the chamber. No continuity. As soon as you get a slide in there, there it is. When you hit it forward again, it breaks contact until a new slide is in, then there's continuity again. It does that over and over again. Every time there's a new slide, it breaks contact as it's changing. As soon as the slide is chambered, you get a connection. And then when there's no slide, nothing. So this would be pretty neat for attaching at least to the focusing waking part of your camera. So as soon as a slide is in the chamber and it's opened up, it can take a reading right away. If you want to have it autofocus, that takes time for it to focus and to meter. So that would really give you a head start if you're trying to get some high throughput on this thing, that it starts metering right away. Or you could tie the wake and the shutter together, and so this thing will fire the camera for you as soon as it has a seated slide. If you did that and then had a pulse unit attached to this that would set a pulse very quickly, you could have an amazing output on this thing. The only concern is that you might want a little bit of a pause after the slide is seated, because there might be some residual vibration in the unit, although I'm not really feeling any. Once it's seated, it seems like it's secure, and in fact the whole thing has barely, the only real click is right at the start when it starts advancing the slide. But anyway, if you did do that, you would use a pulse unit, and I'll show you one that's an off-the-shelf unit. Okay, instead of the mechanical advance, you could use something like this Uno 4 to 30 volt 10 amp blinking flash module. You could feed 12 volts into it. You could set the on time for when it advances the slide. This slide projector needs just a fraction of a second to tell it to advance, so maybe like an 1/8 of a second or a 20th of a second would be your on time. And then you can set the dwell of off time while it's waiting for the camera to take the picture. That can be anywhere from 1/100th of a second to 15 seconds. So here is going to be your advance time and then your dwell time before the next advance. And you would attach this. This is going to put 12 volts out. So you put this to a relay, and then the relay you would attach your camera and your focus to the normally open part of the relay, so you wouldn't be getting any voltage out, you would just be getting a connection. So this and a 12-volt relay, you'd be in business and you wouldn't need my mechanical system. But I'm going to continue with the mechanical system because you may not have this feature on your slide projector, or you may have some other manufacturers and you don't want to do any modifications on your slide projector. You want an external system that will advance the slide projector and focus or set the exposure and fire the camera, and do that in a cycle that you can set the timing on. So let's continue with that. Here's how the install ended up looking. You have this spring-loaded caddy in here. I don't know why it would be for the power cord when you already have this to wrap the power cord around. So who knows what this is for. Maybe for putting the remote control in there or something. But anyway, there's still plenty of room for the remote control. We just have one little RCA jack in there. And that will be handy if we decide to go with that option. So there you have it. Again, for the lamp that we're going to put here in the lamp housing, there's our neutral density filter in there. With this one, we had some limited options with the stock unit because of the strange shape, this small MR13 bulb. Now that's because this one takes a FHS bulb, and so we put in an EZE bulb instead, which is 150 watts. But if you have a unit that takes a standard 120 volt MR16 bulb, that's 300 watts. Let's say it's let's say an ELH bulb. That one is an MR16, 120 volts, 300 watts, no front glass on it. It's a halogen, quartz halogen. That I would recommend replacing with an Ushio ESD. The ESD bulb has a color temperature of 3350 K. It has a nice range, so you'd have a good output, much better than any fluorescent bulb, any LED bulb you'd put in there. And it also has the exact GY 5.3 twin blades. You wouldn't have to make any modifications to your projector. So again, if you do have one that takes your standard ELH 120 volt, put in an ESD. But here, if you've got something that has the FHS bulb, then go ahead and put in the EZE bulb, which is also has a GX 5.3 base, and it is the small MR13 sized bulb. And those will be drop-in replacements. And there it is, with 150 watts, 3 stops down, and a diffuser. It's looking real nice in there and not too bright for the camera. So that should be really, really nice. This slide projector is going to have no problems keeping a 150 watt bulb cool. If it can keep the 300 watt one in check, it's not going to be any problem with your 150 watt one. And not only now do you have the heat absorbing glass and the condenser, but you now have a frosted piece of plastic and a neutral density filter shielding your slide. And so the amount of light coming into the slide is now really reduced, and the heat should not be a problem either. So I'm pretty confident that it's going to be gentle on your slides. And of course, you're going to be scanning them so fast it's not going to be exposed to the light for long. So I think we're in good shape here to continue. Okay, popping it in here. Looks like I'm getting 640th of a second at f8 at 200 ASA, and I'm almost filling the frame, but not quite. So I might have to use a teleconverter to really fill it, or maybe it's not so important to fill the frame because I wanted to get the whole frame and some space around it anyway. So there's a preliminary test. I'll try it with a teleconverter, but I'm generally pleased with it. One optional thing to do is to put some stabilization feet on the front so it's not teetering on this rise. You're not going to have it rise anyway, so I would get a couple of feet or just some pucks of rubber, hard rubber. Cut them so they're just a little bit deeper than this, so it's not teetering on that, so a little bit thicker, and then just stick them on with a little two-sided tape. You can always remove them later, and you can still use the rise if you want to use it as a slide projector. But it's nice now that it's on 4 feet, and you want your slide to be as steady as possible, so why have it on just 3 feet? This is much better. Another option is to put some non-reflective tape or maybe some velvet wrap inside a tube inside the chamber where the projection lens was, because there's a lot of reflective surfaces in there. And I'll show how to do that, but it's not necessary. Get yourself some heavy cover stock, maybe 110-pound paper, and roll it up in a tube shape to get it preformed as a circle. You'll need some two-sided tape, or if you have some rubber cement like you'd use for drafting, get some of that, some contact cement. And then if you have some flocked velvet, which is really drinks up the light and doesn't have reflections, get that. If not, some black felt, black cloth, something with a matte surface, and then we are going to make a cone and line it with the felt. You're going to need about a 4x7 piece of felt. Since you're going to be cutting it down, it's okay to cut it a little bit larger like this, and we'll end up cutting it down to about 3.5 by 6.5 inches. But for now, it's good to have a piece that's a little bit larger. Same with the paper. Cut this down to about 5x7, and then we'll attach the two-sided tape. Apply a very thin coat of the contact cement to the inside of your tube and to the back of your velvet medium, and then allow it to dry, and then you would just nest it in there, applying it carefully because it's going to grip. Or just line this in. Again, it should already be preformed as a circle, because that way it won't buckle and tend to lump up when you curl it up, because it's already in that curled shape. So here it is. We've got it lined, so now it's time to press the felt in there. So we'll start on one side. Looks like I still have some paper on there. All right. So here we go. We'll start here. Keep it curled. Keep it curled. Roll it out. And now we have something that's nicely lined with the velvet. Now that it's lined, we'll take it to the paper cutter and we'll cut it down to our final size, which is 3.5 by 6.5. Did I mention that we're curling it on the 6.5 inch side? Well, we are. We'd only have to be 3.5 inches deep. So we come here to 3.5, about right there, and that's all we're going to need. It's a piece just like that. I don't know if you can see in there, but that is perfection. It goes all the way back to the gate, and of course, if you were to cut this out with a Dremel so you could get your shorter lens and really get in there, of course you'd cut it shorter. But here it is on a stock unit that I'm going to use a 105mm lens, so I don't have to hack apart the slide projector to fill the frame. But there it is. All I had to do was curl it up a little bit smaller than the unit to get it in there. And once I seat it all the way back, you allow it to open, and it immediately takes the shape, and it is seated in there, and there's no reflections with this flocked velvet. It just drinks the light up. Amazing stuff. But regular black construction paper or felt, whatever you have, will work just fine. So on these optional items, obviously you don't have to put these extra feet on, and you don't have to put the anti-reflective material inside the barrel area. But if you're going to be shooting thousands of slides and you want them to be as crisp and sharp as possible, it's worth taking the extra steps. What will we set the camera on? Some sheets of cardboard, CDs, bad dime novels, bad science fiction, bad romance? I don't think so. I think a tripod off the table would be pretty good. Maybe if you had a focusing rack. But changing the height and changing the angle are going to be a little tricky to do the fine-tune adjustments. But again, a focusing rack would help you a little bit in terms of moving the camera in and out. But I'd recommend having the camera on the table, on a platform. And this is a very quick and easy thing to make for holding your camera steady. And you can make fine adjustments to frame up any skew in the slide and change any elevation problems, raise the whole thing up, lower it by a fraction of an inch, and put a little level on it so you can make the level as the slide projector is. And so what I did was I just took a piece of metal from a discarded piece of equipment. It's very thick, so there's no flex whatsoever. It is very, very solid. I drilled a couple of holes in it, and I put a couple of bolts, 3/8 inch or 1/4 inch in diameter, maybe 3 inches long, at least 2 inches long, so you have some flexibility in terms of elevation. I used some thumb screws and other ones that had knobs on them, but you could just use regular bolts and they'd work just fine. Just epoxy some nuts on the bottom, drill a hole for your camera mount. That's going to be your 1/4 inch 20 pitch mount, and you're ready to go. So here's the camera as it's mounted on its stand. You'll notice that in addition to the 105mm lens, I decided to use one of the extension rings anyway. Could have used any of them. I just wanted to be able to get in a little closer than 1:1 if necessary. So that gives me a little bit of an option there. Another problem with the slides is that they all have to be oriented horizontally, not vertically. So you're going to have to make sure that your slides, if you're using the stack loader, that they're all oriented horizontally. If you're going to take a whole carousel full of slides and scan them all as they are, vertically and horizontally, without checking through them, you could bring the camera back and shoot the entire area inside the gate, and then use maybe Photoshop later, and once they're separated out, you could just run a script and batch process them all and crop them right to the image for horizontal or for vertical, depending upon which they are, and just have the program just do it automatically. It's better to get everything on the slide and then crop later than to have anything cropped out while shooting. So if I am shooting just horizontally and I'm shooting the entire slide, I'm going to have it backed off and show the entire frame around it and not crop into the slide at all, because I want to get everything. And again, I can always automate in Photoshop and crop them all at once if I want to crop right to the image or into the image. The first step is going to be to splice into the remote control jack of your slide projector. If you don't have a remote control, you can open the case of the slide projector and tap into the slide advance switch. I had an old Bell and Howell from my aunt that used a sonic remote control. The remote control struck a tuning fork and the slide projector had a microphone. So obviously to work on that projector you'd have to go directly into the switch. Here on the Kodak Carousel I'm going to tap into the remote control. I could just cut the remote control cord and tap into the wires, but then I wouldn't have a working remote control anymore. So instead I'm going to put a tap right here on the control itself. If you don't have your remote control because it's been lost over the years, you can go and tap right into the socket of the slide projector. Here's the pinout. Don't forget, this is the pinout. As you look at the switch, it's going to be reversed left to right. when you're looking at if you're going to tap the wires right into your slide projector, but the center tap is your common ground, and for some reason it's a yellow wire both inside the slide projector and inside the remote control. It'll be right here in the center. Then your slide advance is one of the more narrow pins, and this is as you're looking at it over here on your cord with the narrow ones over here. Inside the slide projector, for some reason it is green. Here on the remote it's red. So what you're going to do, if you want to put in a tap, there's a spot where there's some space inside your remote. So you get your remote control like this over here, and you'll drill in where you have a space. So it's going to be in this corner is where you'll have the space, but don't drill right into the corner because you need enough room to put your RCA jack. So what you would do instead is give it just a little bit of space, like around there. And there you have it. Then you're going to take out the 3 screws on the bottom. And there you have it. Remove the mechanism if you wish. There's the rocker switch. This one does not have the focus control because it came off a cheap carousel model that does not have a motorized focus. This one over here does have the motorized focus. It's right over here. And it's using just one lead because it's going through a diode and it's changing the signal. So this is an unused pin. This is your focus pin. It's a single pin right over here, this black lead. And then the reverse is this one over here. It's this white lead. So you're only interested in the red advance and the yellow ground. So here you're going to put your RCA jack. I picked RCA jacks because they're cheap to buy, and they everybody has RCA patch cables from their VCR or their CD player or whatever, so they're already out and about. So you're going to put that there, and then you're going to solder in the leads. You'll solder the red lead to the center, and you'll solder the yellow common lead to your ground lug on your RCA jack, and then you put this back together. Sorry to confuse matters by using some random colored leads of my own, but you can see the ground lead for the slide advance is here in the center. It's this yellow line right here, and to it I've soldered a line to the ground. The red line to this first one is your slide advance, so that's their positive, and I've got that running to the positive line. Disregard the color of my lead, I just grabbed a random wire. So here again you can see it a little bit better. On the flip side, here's your positive lead for the slide advance. This is for the slide reverse. These two are for focus, if you have a focus model. So don't use these, don't use the reverse, just the red advance, and put that to your positive, and there in the back your yellow is the lead that will go to your negative. And when you've got it all together, you have them right here. You can test it out, put in a multimeter to it if you wish, put on the leads, and you can see there's nothing here on the reverse, but then if you press that, there you go, there's your forward. You can see it on the meter. So we're all set. Time to put this part to bed and go to the next part. You'll need to interface with the camera's electronic shutter release. The easy way to do it is just to get the right cables. This is the one for this Kodak D800. This is the interface. I got a cable that goes from that to a 3.5 millimeter stereo jack. From there, I just use a 3.5 millimeter female stereo jack to twin RCA plugs. One is going to wake the camera, one is going to fire it. I had to test it to find out which one was which by testing the pin out. You can see here that there is a set of pins and there's 3 tabs. That kind of tells you how it registers into the camera. And this is the pin number 9 that focuses the camera. This is the ground down here at the 5 o'clock position, and the shutter is here at the 2 o'clock position. The way these are set up, you have to have the camera woken before it will shoot. You could tie the 2 leads together, the shutter and the focus together, and when they're both shorted to ground, it'll fire the camera and wake it at the same time as soon as the camera is ready. There could be a pause if the camera is set on autofocus. But one way or another, you have to have the wake and the ground together before the shutter to ground will actually fire the camera. So on this, I put this together. I used a multimeter. I went to the ground. Both of the grounds are shorted to each other, and sure enough, it leads right to the ground lead. I put the meter on the white one, and it is going to the shutter. The red one is going to focus. That was not intuitively what I thought it would be. So on this one, I'm going to have to put a couple of tags on it and say this is the shutter and this is the focus. If you didn't have a hardwired system like this is not available for your camera, you're going to have to tap into the remote itself, and I'll show you that. Here's your typical remote unit. It's going to have 3 tabs. Again, you're going to have to use your meter and find out which one is the ground, which one is the focus, and which one fires the camera. Usually it'll be in that progression from top to bottom, ground, focus, camera, and when they're all pressed together, that's when it fires the camera. And you could tap into the appropriate leads, 2 ground leads here going to 2 RCA jacks, and then the focus and the fire. And what you'll end up with is something like this here, where you have it going from the camera, and now you can still use this remote control to focus and fire, but you can also tap into it, focus and fire right there, like that. Same way with this one over here. This one goes to a Sony Alpha R2. This one goes to a USB port on the camera, but it's the same thing. You're going to have 3 leads in here, and you would put in the appropriate taps so you can tap into it. Here's a demonstration of the leads. You can see that if I jumpered the camera firing one, it's not going to fire the camera. If I jumper this focusing one, and you watch here, as soon as they touch, it will wake up the meter, wake up the camera. Once that condition is satisfied, then you can jump this and fire the camera. Time to select a project box. We're going to use a rotary switch driven by a gear motor to set the firing order and timing of the slide projector and camera, and a project box to house this distributor assembly will keep things neat and make timing adjustments plug and play. You could use an actual project box or a cigar box. I'm going to use this cardboard box. It's because we have plenty of these. These were meant to house, I think, 105 millimeter microfiche rolls, 500-foot rolls, or whatever. You know, nobody shoots microfiche anymore. So we're going to use this box. It's acid-free. Yay! Okay, so we're going to drill some holes in it, 6 holes. One is going to be the output for your slide projector trigger. And then we're going to have 5 more. These will be in sequence, ones that will set the focus and the shutter on your camera. So drill them all out and then put in some RCA plugs. Maybe color code them. Maybe black could be the one for the slide projector, and that will go first because you're going to advance the slide, and then have 5 of them all maybe red, and have red always be your camera oriented outputs, and all the black ones be for the slide projector. That way you're always putting colors to colors and you can't make a mistake when attaching your patch cords. Undo the RCA jack assembly. Push your RCA jacks through, and since they're going to use a common ground for all the camera ones, and then a single ground for a separate circuit for the slide projection switch, daisy chain together 5 ground leads, and just use, for simplicity, some already stripped cord, or I just took apart a USB cable and there was already a ground cord that was unsheathed, so it made it very easy to do this. And you'll find all the small gauge cord that you need within a single USB cable, and they'll all be color coded, so you can use the red one for your camera and the black one for the slide projection. So solder these leads and then attach them in and torque them down. A moment of silence for our dead USB cord. And here they are, soldered together. And I put a black lead on this one for the slide projector and a red lead on this one for the camera focus and camera advance. So now they're ready to put on, and then put the fastening nuts on them. Here you have it. The RCA jacks are installed. Locking down those nuts will be easier if you use a socket wrench. But once they're snugged down, we're ready to proceed. Solder 6 signal leads, 1 to each positive terminal of the RCA jacks. 5 of them will be shutter release. 1 will be a release for the slide projector. The heart of the distributor is this 2-pole 6-position switch. It's a $3 part from Amplified Parts, number P-8392. It's a very simple switch. It has 6 detents, 12 contacts, and it has a single wafer with a contact on each side going around, and there's a stop that stops it from proceeding any further. This one over here will come to this part over here, and then on the other end of the travel over here it'll stop it. We don't want that. We want it to keep going in circles. So the first step we're going to do to modify our switch is to come in here, and you'll see the stop is in there, and you can see it right here. You're going to take that and bend it out until it is no longer going to hit these guys. So just bend it out, and then it'll be free to turn all the way around in a circle. The next thing you don't want those click indents, because the indentations will give it a bulky action, and you just want it to have a smooth turn in a circle as the motor turns it. So you're going to take this detent ball out. Should be pretty simple. There it is right there. So you'll just come in, and you should just pop right out. You might have to bend this out of the way first. There it goes. Hey, and it's gone. Now this thing will just turn easily in a circle. If you look at the contacts, you'll see that there are 2 poles. One of these, and here's a registration part on the top here, so you can use that for reference to see where we are underneath. Since the motor is going to turn it clockwise from underneath, it's going counterclockwise. So this one over here will be your you'd attach to the ground for your slide projector switch. This one is going to be the ground for the shutter release, because it's a common ground on the shutter release for both the focus and for firing the shutter. Then, as this goes around, it's going to sequentially make contact with positions 1, 2, 3, 4, 5, and 6. And at the same time that slide number 1 is firing, it also makes contact with camera number 1 and goes 1, 2, 3, 4, 5, 6. That's a half turn. Then the other set of contacts are going to make this contact again on the second half, because now you've taken away the stop. So for every turn, the camera 1, 2, 3, 4, 5, 6 is going to repeat. So you're going to have 2 actuations of the camera on a single turn. That's why we're choosing a motor that has a slower speed. The motor that goes 18 revolutions per minute will fire 36 times with the camera and the slide per minute. The one that is 10 RPM will fire it 20 times, which is probably fast enough, gives you some wiggle room for making some adjustments. You could successfully use the 18 to /36 frames per minute motor, but you're cutting it kind of fine when it comes to having the camera focus in time and having the slide projector advance in time before the next firing cycle. So make life easier for yourself and get the 10 revolutions per minute motor. So we're going to attach the ground lead, the black lead, from the RCA jack in your box, and we'll put that ground lead to this one here, and then we'll put the hot lead for the slide advance in position number 1, slide 1, which is right over here. We don't need to use any of the other slide ones, because the slide projector is going to advance first, and then the camera is going to advance sometime after the first one. That's why we're not using camera 1. We'll use camera 2, 3, 4, 5, and 6, and put them in sequence 2, 3, 4, 5, and 6. So it's time now to solder these leads, and of course the ground for the camera is going to go right here. So it's time to solder these leads to here, and here, 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 and here. And we'll get them all soldered in. Even with the detent ball removed, you may still have to bend the tabs that were holding the detent ball in place. So again, we have to remove this stop over here. Just bend it out of the way. So come right in. Just give it a bend so it no longer stops. Then you're going to have to turn it. There's your detent ball, and here's the part that you're going to have to bend out. In fact, you may even be able to keep the detent ball in there if you come in and have less pressure on it. So if you come in where there's a big bend, and bend it out of the way on one side, and do the same thing over here where they put a crimp in it for the spring action, and move it out of the way like that. And again, your stop has to be moved all the way out of the way. Here's your stop. Bend that out so it's straight out. Now you have something that will turn freely all the way in circles, and you can leave the detent ball in. In fact, it helps press the whole armature down for making contact. It's optional. You could take the ball out and it still works. But if you want to leave the detent ball in, now it turns all the way around in circles. Finishing up the project box, you need to introduce power for the motor. And you could just put a hole in the box as I did here, or you can put in some kind of panel mount that's the appropriate plug for the AC adapter that you have. On this 18 RPM 36 cycles per minute setup, I have a 24 volt motor because I just happen to have a 24 volt AC adapter. On this one, which is the 10 revolution per minute, 20 photographs per minute, I'm using a 12 volt one because I just happen to have a 12 volt AC adapter, and there's your input for it. These motors, which is the most expensive part of this control unit at $10.25, I'm really impressed with the quality. It's really a nice chunky unit, fairly quiet, very powerful. So couldn't be more pleased with it. The output shaft is 6 millimeter, and the shaft on the switch is 1/4 inch, and that's 6.35 millimeter. But luckily these connectors, which are flexible, which really allows for a little bit of error in alignment, come in all kinds of sizes, and this one converts from 6 millimeter for the motor to the 6.35 millimeter or 1/4 inch for the shaft. So perfect. The only thing you have to do is keep this switch from turning while the motor's turning. So this you glue to the bottom of your box, and this you're going to have to affix in some way. I put this little bracket on it, and it's going to sit on the sidewall. So when this plugs in over here and you get this plugged in, this will be sitting on the floor, and this will be mounted to a wall. You could also mount it to the floor, whatever you want. On this one I built a little wooden crib, but you don't have to be all that fancy. Just some way to keep this from turning. You could even fix a little screw into one side and have a standoff to the wall, as long as it doesn't interfere with the turning of the switch. So there's a lot of different ways to do that. But once this is installed, then it will be turning, and we'll test the unit by putting a signal into it. Before I attach the rotary switch to the motor and it spins at speed, I'd like to show you exactly what's happening as it turns, and we'll do that in slow motion. Let's attach these test light bulbs with a common ground, and then to the positive lead for these light bulbs we'll attach it to the camera in lead right over here, and see if we can't get something to illustrate what's happening here. Okay, so as we turn this, okay, you're going to see that's position 2, 3, 4, 5, 6, back to 1. 1 isn't lighting up because that's a separate circuit. If you remember, that's the black lead for the slides, so that's not turning. So we have just 2, 3, 4, 5, 6 going, and then 1 is not happening. Okay, but what if I turn it slowly? You will see that between the switches, see how they're both going on? This is a shorting switch. So the idea is that you will always have one of these going on. It doesn't turn one off before the next one goes on. They're both on just for the merest moment before the next one kicks in. So the idea is that if you had, say, this one, and this one to focus the camera, you could tie them together with some jumpers on the inside and have, say, the focus plugged in here and then the camera firing here, and you could have a couple of these to give some dwell time before you fired the camera. And of course you have to have the focus attached before the camera can fire anyway, because both the focus and fire pins have to be shorted to ground to fire the camera. So there you go, you're coming through here, and it's going to sequentially go through these. So the idea would be to have your slide projector fire first, and then it would advance, give it time to advance, maybe have it start focusing here, have it continue to focus, and then have it fire the camera, and then have time for the camera to fire, and then have the slide advance. Here it is in action. Of course, the slide is on a separate circuit, so if I were to disconnect that one, you would just see the camera operating and not the slide. So the slide will advance. This is position 1, 2, 3, 4, 5, and 6, 6 being the slide. So if you gave the slide some time to advance and started focusing maybe here or here after the slide has advanced, you could gang these together, have them all give the camera time to set the exposure if it's not on manual. And then this one here could be the one that actuates the shutter. And this is the 10 RPM motor, so you're having 20 actuations per minute. Let me put on the other box now, and I'll show you the one that shows 36 actuations per minute with the 18 RPM motor. This one's running at 18 RPM for 36 cycles per minute, and you can see that I put in a full bank of 6 positions for the camera and 6 positions for the slide advance. That's not really necessary. This was overkill. Plus I put it inside a wood crib, but I left the detent in there so you can see it clicking away a bit, even though I took some spring pressure off the detent. But I think at this speed you'd be cutting it a little bit fine. I know that you, also I ran it in the other direction on this one. It doesn't really matter. Just pick one as pick one as your slide, or this one over here, and then the other one is going to be advancing in a certain direction. But on this one here, I would set maybe the slide advance, and then I would gang together at least 2 of these, maybe 3 for the focus or for the exposure. That's not necessary if you're going to just wake the camera and shoot it in a manual setting. Then you can just do it simultaneously with the shutter. But I would put the shutter maybe here, give the shutter time to shoot, and then have a little bit of dwell before you advance the slide. And as soon as the slide advances, it should be pretty quick, but I would put it over here, maybe jumper these 2 together, and then have the camera shoot on this one over here. But again, this is going to be really, really fine-tuning because it's going so quickly. I'd recommend not getting the 18 RPM motor. I'd really recommend getting the 10 RPM motor so you have a little bit of flexibility with the timing here, and you can have some leeway with the dwell time and not have it so fine-tuned right to the wire. In this setup, I'm using the 10 RPM, 20 exposure per minute motor. I have the progression coming here. I've got the wake starting in position 2 because I've jumpered between 2, 3, and 4. So all of this is going to be wake. It's all tied together. So what's going to happen is we're going to advance the slide. We're going to give it some time for the slide to seat itself. We're going to start metering or focusing, and I've just got it on meter because I think the focus is going to be fine throughout the whole thing. We're at a fixed plane. I'm just going to meter for every slide because some are very dense and some are almost opaque and some are washed out. So we're going to have a dwell between 2, 3, and 4 of having the camera wake, and then position 5 we're going to fire the camera. The camera is going to fire, and then the slide is going to advance to the next slide. And also, when it's seating itself, this gives it lots of time to make sure there's no vibration in the unit from having advanced the slide. Now you might be wondering how it's going to shoot because the shooting itself has to happen with the wake also contacted. But don't forget that this is a shorting type rotary switch. It will connect. It will not disconnect this one until it connects this one. So for the merest of the moment, both of these are going to be on. So here we're going to come across nothing, wake, 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 and then before the wake turns off, it will fire the shutter. So it's just for a fraction of a second. If that didn't happen, we'd have to put a jumper in here and tie them together to make sure that the wake was on while the shutter was going on. So let's give this a try. We'll plug it in and we'll get going here. And you should see the R and the thing showing it woken, and then you'll hear the shutter, and then you'll see the advance. Bring it up to a high beam. So you can see it's giving plenty of time to analyze the slide before it shoots. Now with this setup, there's no sensor saying that there's no slide in the chamber. So you're going to have to be here to turn it off when it's done, because otherwise the slide will not only keep going, but the camera is going to keep going when there's no slide in the chamber. So let's say you shot this whole thing and there's nothing left. We'd unplug it and we're done. And we can unplug the slide projector, but we're not doing any camera. So that's that. It's looking pretty good. I think on the next video I'm going to talk about calibration of the camera, ideal settings, how to take a gray balance reading off a test slide, all the little fine-tuning things to get the best quality. But I think for now we've really covered everything we need to in terms of how to get this thing going. As I said before, if you do tap into the slide projector itself, so the slide projector is telling the camera to wake, you can have much faster times. And maybe in the next video I'll show how to hook up a relay to that pulse module, so you can tell the slide projector to pulse with a certain amount of pause. And that should give the output to be much, much higher. We might even be able to do maybe 40 or 50 slides per minute. But as it stands, I've had a successful test with 20 slides and 36 slides per minute, and the thing is chugging along pretty nicely. So I'm pretty pleased with the build, and I hope this was helpful to you. It was a pleasure for me to photograph this along the way, and I hope it helps you. Well, here's an addendum to the video. The electronic module came in that will allow you to send a pulse to the slide projector without using my distributor system. This module by czh-labs.com is a pulse module that will have an on state of anywhere from 1/100th of a second to 15 seconds, and then it will have a time that it's turned off. That's your dwell time between, again, 1/100th of a second and 15 seconds. You can put in a voltage anywhere between, I believe here it is, 4.5 and 30 volts DC, and it will give you that voltage out with a pulse. Now we don't want a voltage out because we're connecting switches, so I put it to a relay. I would have preferred a mechanical relay where you have a definitive on and off state, but I just happen to have this solid state relay. And so you'd put in an appropriate voltage for your relay. Let's say it's like a 12 volt relay. With the solid state one, you're going from a high resistance to a low resistance, which is pretty much an on-off state on the switch side. The reason I want a mechanical one is because sometimes you need a certain trigger voltage to get it going, but it seems to be working here. So the solid state one will do. So I'm going to put in voltage here through my AC adapter to the voltage in. The voltage out is going to my relay, and the relay is just switching on and off to tell the slide projector to proceed. I could have one of these also set off the camera. I could set off a reverse on that of the normally open and have the off state instruct the camera to shoot. But here I'm going to use that relay that I put inside the slide projector that tells it when the slide is seated, and the slide projector is going to tell the camera to fire. So let's set this down and we'll put the slide projector firing there, and we'll put in the input. This one is working off 9 volts because that's the specification on the relay. And you'll see it's going to pulse on, and then it's going to pause and pulse off. So let me unplug it for a minute. Let me take this off so you can see it better. These turn many times, so you can really get a fine tuning on the on and off setting. Then we're going to attach the camera, and again it will only fire when there's something in the gate. Another thing I did, I put this on a manual setting. I tied the shutter and the wake together, so it will wake the camera and fire it together at the same time as soon as the contact is connected. So here we go. Let's start it up. You can see that it is already pulsing. So here we go. It's not firing the camera yet because we don't have a slide in the gate. I've got about 30 slides in here. So here comes, oh, and the light is on full beam. There we go. There's our first exposure. And I've got it on live view, so I can turn the live view off, and that will go even faster on it. So let's do that. Let's start over. Because I was doing some critical focusing. I had the live view on. So let's turn the live view off, and let's step up the pace here. So it's not, so there's less dwell. Here's your on state, off. You want it on just long enough to fire the slide projector, but not have it fire multiple times. So you might have to play with that. You might have to back it off so it's more of a blip. So let's make it faster. So it's a fire, 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 fire. Let's go even faster. All right, let's fire it up. Here comes the first one. There's your fire. Second one. And I think I could go even faster than this because I hear that there's a little bit of a dwell there before it goes. Let's speed it. Well, I gotta go the other direction. I want to go faster. Didn't fire because there was no slide there. There's another gap coming up right here. No fire. There it is running through them, so that's working out pretty well. Let's just take a look at these real quick after it finishes. Alright, that's it. Let's see if we can take a look at these. Alright, let's roll through them real quick. Alright, the exposures look pretty good. It looks like it's filling the frame. These are duplicate slides, so a lot of them are the same image. Alright, excellent. Alright. I think that concludes it then. One other thing, this is untested, but this is one way of using the electronic pulse module instead of the mechanical distributor assembly to fire the camera, wake the camera, and advance the slide projector without altering the slide projector and using the slide projector to shoot the camera. In this instance, we're going to apply, this is untested, but this should work. And I'll put the parts in the description. You'll need this pulse unit. You'll need a delay unit, which is very inexpensive. It's like $2 postpaid. And you'll need a 12-volt relay. You can get a pack of 5 of them, or a pack of 10 for about like $8, something like that. They're about $1 each. Tops. So this is a pretty economical unit that will go to wake your camera, and of course you'll still need a couple of connector plugs that are the standard RCA panel type. But this can all go in a little project box. So you're going to apply 12 volts DC using your AC adapter or a 12 volt DC power source to power the pulse unit. And of course the pulse unit will then send a pulse of that voltage out. I was proposing that you have this maybe pulsed so it will stay on for a long time, maybe 1.5 seconds, and then have a short duration when it's off, only quarter of a second. So the output is going to go two ways. You're going to have it power this relay, and when the normally closed way will go to the slide advance, so it will be open. The slide will not advance when this is energized for the 1.5 seconds. However, because this is normally open, this will close, and so for 1.5 seconds the camera will wake up and actuate the meter. After about, set this delay unit, this delay is getting power, set the delay for maybe 1 second. After 1 second, the wake state will still be activated, but then the shutter will be activated. So you will have the camera already woken for a second. It will fire the shutter, and then after the 1.5 seconds is up, it's going to go to the off state. The off state will shut down your camera wake, and it will shut off your camera shutter. But it will advance the slide. So this has to be set short enough that it doesn't advance two slide settings. So just set it to the maximum before it would advance the slide twice. By shutting off everything, that will reset your delay module. So when it's finished being in the off state and it goes back on, it will immediately hit this relay and wake the camera, and it will set the 1 second delay before hitting the shutter, and the cycle will go over and over again. So here's a electronic pulse way of not using the electronic distributor. I kind of like my distributor because I put it together and I'm kind of fond of it. But this is definitely, looks like it will be a good alternative method. I haven't tested it, but there's no reason why this should not work instead of the mechanical unit. If you have stacks of slides and they're not in carousels, you're going to need a stack loader. Kodak made two different kinds. I think one was called the something 40. It's for the earlier ones. Since this is a more modern, I guess maybe 1980s or 1990s projector, it uses the Kodak EC. But of the two models, you get your appropriate model. When you're taking out one of these, if it's not centered at the 0 point, you press this down, bring it to 0 before you remove it. Now you can remove it. For a stack loader, it's got this registration thing right here. You just drop it right in and it's in. Then you bring this over, take a whole stack of slides. There's actually a clip, which I do not have, but that helps you hold them without dropping them. So you get them in there, and as you remember, I've got my slide advance plugged into my distributor here. It's running in this direction, so after it shoots the slide, I've got the wake here. I've got these daisy chained together with jumpers so it'll stay woke long enough to give the camera time to do what it needs to do. Here I've got it doing an auto exposure, and then it's going to fire the camera right before advancing the slide. So here we go. Let's put some power into the thing here. And you can see it's giving it plenty of time to decide 250th of a second, 200th, 320th, and it also gives it time, if there's any vibration in the slide projector, for things to settle before it takes the picture. And it's going through them sequentially. And when you're shooting like this, what you're going to want is the lights out. So there's, I mean, even though we've got the camera right up to the slide projector, almost touching it, and we have velvet lines inside there to get rid of extraneous light. You should get rid of all extraneous light in the room and just allow this to do its thing. But you can see that this takes a lot of the tedium out of doing a large number of slides. I'm using my slow distributor. This is the one that goes 20 cycles per minute, 10 RPM. It gives me lots of maneuvering room for fine-tuning. Here's the final segment of this video as an epilogue. I made this out of a project box of one of these Bell & Howell slide projector trays, of which I have a ton of them. And this is the reason why I started the project. If you have a slide projector that has an auto advance and you have many slides, and in this case this goes into a magazine and each one is individually plucked out and pulled into the slide projector in a frame. If you were to pull each one of these out and put it in a scanner to scan it, it would take a very long time, especially if you had, say, 50 of these boxes. Here, this one is this was taken in 1965. These are street scenes in Puerto Rico. This is going to be some interesting stuff. You know, some of them are going to be better than others, but to have these all pulled out and scanned automatically is really going to be fantastic. When it comes to the two systems, I like my mechanical system better. That's just me. But either way, if you already have a slide projector and you have a SLR, digital SLR, or a digital rangefinder, and you already have a macro lens, the investment here for each of these is less than $30 for the parts. And so they're easy to put together. Hacking into the slide advance was very easy, just going into the remote control or putting a couple of pins into the advance bus on the side of the slide projector. There's already off-the-shelf cords for your given camera, so tapping into that, as you saw, was either a simple matter of wiring into a remote or using an off-the-shelf connector, so you don't have to do any wiring whatsoever. It's all plug and play. So if I can do another video sometime, I'll talk about calibrating the camera, getting the best results there. You saw, to get rid of the reflections, we put some felt inside the barrel of the slide projector. If I get a junky slide projector that I don't mind hacking apart, we'll do a couple of other things. Maybe we'll saw it open and we'll use a standard macro lens instead of a macro telephoto. But I think that that should take care of it for now. So good luck, and in the comments let me know if you have any suggestions, any improvements, what your experiences were. And I hope this is beneficial for you. And I'm going to put this thing to work right now and scan a couple of thousand slides. So take care.